Hi Whiz Kids and welcome back to Science with Sophie. I hope you're all doing really well. Today's first experiment we are going to be making a lava lamp out of oil and water. So what you're going to need is some baby oil or some vegetable oil or any kind of oil, some water and some food colouring to make it look pretty, and also some form of antacid or any tablet that fizzes when you put it in water, which will make the bubbles for the lava lamp. So let's get on with it. So you're going to take some form of bottle or glass or anything, the clearer the better, and you're going to start pouring your oil in. So I'm using baby oil, but once again it doesn't matter if you use vegetable oil or anything. So once you've added all your oil into your bottle, you then are going to take the water, which I've already put some red food colouring in, but you can put any colouring you want, and you're going to pour the 1/4 cup of it into here. So just notice what happens when you pour the water into the oil. Just wait for it to settle for a second. So as you can see, the water has gone straight to the bottom and the oil has stayed on top. So this happens because oil is less dense than water, or another way of saying that is oil is lighter than water, because density, all that means is how heavy something is. So if something's less dense, it means that it is lighter than. So you're going to take your tablet, you're going to place it in the cup or the bottle, and let's see your lava lamp. So if you shine a torch behind it, it will also look pretty cool. So let's do that now. So this works because when you put the tablet in, it creates carbon dioxide, which is a gas, and that is lighter than both water and oil. So it attaches to the water and brings the water up to the top, and then you can see that there's bubbles here that have created, that's all carbon dioxide. So once the gas has got to the top and made this Fermi layer here, the water is then heavy again because it hasn't got its carbon dioxide and sinks all the way to the bottom to then get some more carbon dioxide and bring it to the top, which is why it's going in a circular motion like that. So that's how this one works, and let's go on to experiment 2. So experiment 2, we are going to be seeing how different liquids stop apples from browning. So you're going to need an apple and a knife and a parent to cut your apple. Please don't cut any apples. And then you're going to need a range of different liquids. I'll tell you the ones I'm doing, but you could also do a fizzy drink like Sprite or lemonade or Coke or anything. So I'm going to be using salt water, honey water, sugar water, just normal water, apple juice, lemon juice and orange juice. So let's get on with it. First step is to cut your apple into pieces. So you need as many pieces as different liquids you're going to be using. So once again, please get a parent to do this because I don't want you to cut any of your fingers off. Okay, so I cut mine into 8 pieces, and I've got 7 different liquids to use, and then the 8th piece I'm just going to leave completely blank and not put any liquid on it. So the purpose of this experiment is to see how much apples brown, depending on what liquids they are. So you probably have seen this when you've eaten an apple, but when you eat an apple, it will go brown quite quickly. And that is because the apple is exposed to oxygen. So oxygen is what we breathe in. I'm just putting the pieces on a plate, spread out nicely, just to say. But this process of oxidation, where the apple gets too much oxygen, which makes it brown, when this happens, something like a liquid like apple juice or water, or we'll see in the experiment will slow down this process. So we're going to see what the best thing is to slow down apples browning. So let's do this. So I've placed the apples on a plate and separate them out, and then I have done labels like this to put next to the apples so I know which one is which. Now we are going to pour on our different liquids, or if it's easier you can even put the apples into the liquid. So this one's just pure water. Just going to pop that in there for a couple of seconds and then fish it out and put it on the plate, and then do the same for all the rest of them. I've done all the different liquids, so now I'm going to leave them for 3 minutes and then we'll see what they look like, and then 6 minutes and then 9 minutes to see the difference each 3-minute interval. So I shall see you in 3 minutes. So it's been 3 minutes now, and not many of them are browning up. The one in the middle is probably the most brown so far, so let's do another 3 minutes and see what happens. So it's now been 6 minutes. Once again, it is probably the one in the middle that has the most browning, but we could turn them over to see. I'm not sure. There's a bit of browning on the one that's just water, and I think, and a little bit on the lemon juice, not too much. Yeah, so it's just actually at the moment the ones that are mainly brown are the one with nothing on and the one with water. So let's go for 6 minutes this time and see what happens. So we just had another 6 minutes, and once again it is mainly just the one with the water and the one with nothing on that are brown. However, the lemon juice has started to go a bit brown on this side. I don't know if you can see. On that side it has a little bit. So what I'm going to do is leave these for maybe about half an hour to see if there is a big difference, and we shall check in then. So it's been about half an hour, maybe just a bit longer, since we last looked at the apples, and not much has really changed. A few of them have browned up a bit more, but not all of them. So the one that was just had water on it is probably the brownest, and the one that had nothing on is then the next brownest. And then the rest of them are about the same. Maybe a honey water is a bit brown as well. I wonder what yours look like if you've tried this as well. But I'd say the ones that are the least brown are actually the ones with salt water on and sugar water. However, I think if you've got an apple in your packed lunch or a snack, and you've got it chopped up and you need to put something on it to stop it going brown, I don't think you'll want salt water on it, because that won't taste very nice. But yeah, that is the one that has stopped it from oxidizing, which was that word we used a bit earlier, saying that when apples go brown. And then probably sugar water is the next best one. So that's interesting. I wonder what your results are. Hopefully they're the same, but if they're not, it doesn't matter. That's what science is all about. So yeah, that's all our experiments for today. So I hope you have a good week, and I shall see you soon. Bye.